And we have just created geometry in the workbench, and now I'm going to create the link between the geometry and the meshing application. So look for the meshing from this toolbox, and you can see here that we have the mesh, should be somewhere here. So mesh is here, and you can either just hold the left mouse button and drop this application on the geometry, and this will automatically create a link between the mesh and the geometry. Or I can right click here and delete this case from here, and I will go back again and double click on the mesh, and you can drag the mesh, let's say here, and then drag the geometry cell A2 to the geometry cell, to the mesh cell B2, and this will create a link between geometry here and geometry here. And now to open the Ansys meshing, double click on the mesh here, and this is showing that it is starting meshing, and in a few seconds it will open the Ansys meshing application here. So just wait. So we have just with us the Ansys meshing here, and this Ansys meshing is different, slightly different than the previous one. Almost I can see that the meshing creation method or techniques, they are almost same, with some addition of the, for example, menus here, and for every menu there are the sub menus, there are these GUI commands here. So you can have the selection, let's say, menu, we have the automation menu, display menu, model menu, and on the tree outline we have the geometry, materials, coordinate system. You can define the local coordinate system, for example. We have the symmetry plane, which is this plane over here. So also transferred from the geometry to the Ansys meshing here. And also we have name selection, which are the boundary conditions for the COD analysis in the Fluent, and where we can provide the boundary condition or values of the variables at the different locations. And here we have the mesh, and by default we have for this case, the CFD. You can change the preference, let's say, to mechanical, to non-linear mechanical, electromagnetics, explicit, or custom, or hydrodynamics. And we have the solver preference. Right now it's a Fluent, so just keep it. And element size by default is 0.011. And if you take a look on the geometry, for example, so we know that if I take a look on geometry and change the units, let's say, to the meters, and units here are also in the meters. So if I want to just analyze my geometry, for example, from tools, and let's say I want to find a distance between the two entities, so I can display for example, the vertices, and I can choose option as the points, the first point and second point, let's say over here. The distance here is the 2.032, and default size is around 0.1. So I can see that I will be creating mesh of around 2 divided by the 0.11. So around 18 elements along the length of this meshing elbow. So this is the meshing size for the volume, and as you refine the mesh in the local area, so mesh will grow. And from here, let's say now I'm just going to, I have some sizing here. So default sizing, we have the quality and inflation, by default number of layers are 5. So now I'm just going to create the simple mesh, which is the automatic mesh, and just click on generate mesh, and this will give us some decent or maybe some very basic mesh, and that will be the mesh. From here I will refine the mesh to the required quality and the number of nodes. So even you can run the case by this mesh quality, this number of nodes, and you can get some basic results, for example. And if you take a look on the mesh, you can see that the mesh is refined in the smaller part, which is having the more sharp curvature here, and as compared to the small curvature. So it has refined the mesh according to geometry here. So this is how you can create the basic mesh, and in the next video I will teach you that how you can create the required meshing quality with the required meshing method.